So we'll go ahead and close the chart editor window, and then we'll go back to our data set. And now I'm just going to create a few values so we can see how that would look. So let's create a value of 0 and take a look at that. So 0 GPA. So go to Graphs and then Legacy Dialogs, and then once again select Boxplot. Click Define, and then everything's good here, so click OK. Our new boxplot is produced, and notice now we have this boxplot that's pretty scrunched in terms of the entire display. And look down here at the very bottom. There's a circle with 11 shown. And what this is indicating is that we have an outlier, and an outlier can be defined as a value that is away from the rest of the values. And this outlier, notice it has an 11 here. This indicates the observation number of the outlier. And we can look here at our axis to see that this outlier has a value of what would look like from this graph of 0. And we in fact know that it is 0 since we just entered it. So this value is an outlier. So this is something we would want to explore and take a further look at to make sure it appears to be a valid value, if this were just a normal data set. And in fact, boxplots can be useful for identifying outliers, or observations in the data set that may be problematic. One example could be data entry, and let's take a look at that before we close here. So let's go back to our data, and then here I'm going to enter a value of 10. Now we're talking about GPA here, so a value of 10, of course, is impossible. We can only have values from 0 to 4. So a value of 10 is far outside of that range. Let's produce a boxplot on these data to see what it looks like. So once again, we'll go to Graphs, and then Legacy Dialogs, and then Boxplot. Everything looks good here, so click Define, and then click OK. Now in the boxplot produced here, notice we still see our 11, which is given by a circle, and that's one of our outliers, which was the 0 GPA. But now we also see this observation, which is shown by an asterisk, and we can see that it's observation number 12. Notice there's different symbols used here. Notice there's a circle for observation number 11, this outlier, whereas for observation number 12 there's an asterisk or a star. What SPSS does here is it uses these two symbols to differentiate between two different types of outliers. A circle can be thought of as a traditional outlier, and it needs to be examined. It's a value that appears to be outside of the data and should be looked at. But if you see an asterisk, this indicates an extreme outlier, so a value that is very far away from the remaining values. So an asterisk or star actually indicates even greater concern than a circle. But both of these do appear to be outliers, and they should be examined more closely to see if they appear to be reasonable values. And if we looked at them more closely, a GPA of 0 is certainly possible if someone received all Fs in their classes. But a GPA of 10 is not. So this would indicate to us that we have an error in the data set. This value right here is definitely an error, and we'd want to double check this one as well to make sure that it is in fact legitimate. Now if this value of 10 was left in the data set and descriptive statistics, for example, were calculated on GPA, then those values would in fact be compromised because this 10 would inflate, for example, the average or mean GPA among the remaining values. So it's very important to make sure that the values entered in one's data file do appear to be legitimate, and boxplots are one way to identify potential outliers in one's data. There are other ways as well, but this is a nice basic way to do that. This concludes the video on producing boxplots in SPSS. Thanks for watching.